Hello and welcome back. In this tutorial, we will study properties of the second derivative of the function. When we studied first derivative, we figured out that first derivative will give us understanding where a function has maxima and minima point. Let's say we have some maxima point in here, and we know that function will be increasing to this point and then decreasing. But which shape the function will take? It might go this way. It may go also this way. So which shape should I choose? On this question, second derivative gives an answer. We have the following property. If second derivative is positive, then the function is concave up. The shape is like this. And if second derivative is negative, then the shape of the function is concave down. Let us do some examples. Let's say we wanted to consider function x cubed. We have to find second derivative in order to find concavity. So first derivative will give us 3x squared. In order to find second derivative, we have to differentiate first derivative one more time. So I take first derivative and differentiate it one more time. So I have 6x. As you see, second derivative is positive when x is positive. And second derivative is negative when x is negative. So we can say that function is concave up on the interval where x is greater than 0, and concave down on the interval where x is less than 0. And if you think about graph of this function, this is just a cubic function. Y equal x cubed. So when x is greater than 0, function is concave up. Second derivative positive. When x is less than 0, function is concave down. Second derivative is negative. Let us consider one more example. It's example from previous tutorial with the function x cubed minus 3x squared minus 24x plus 32. We studied before maxima and minima points of this function. Let's study concavity now. X cubed minus 3x squared minus 24x plus 32. In order to find concavity, we have to find second derivative of this function. First derivative, we found it before. Now, in order to find second derivative, I have to differentiate this function one more time. So I have 6x minus 6. Now we have to find inflection points. Inflection points are points at which second derivative is equal to 0. We take second derivative, make it equal to 0, and we find that we have point x equal to 1, which is an inflection point. Now, as before, we take the domain of our function, subdivided by the inflection point x equal to 1, and now on each subinterval we have to check the sign of the second derivative. If second derivative is positive, function is concave up, and if it's negative, function is concave down. And again, pick any point on the first subinterval, say 0, plug it into the second derivative. You can see that it's negative, so function will be concave down. And if we pick any point from the second subinterval, let's say 10, plug it into the second derivative, you can see that it's positive, function is concave up. Concavity is very important in the application of business. Inflection point is the point of diminishing return in business. And if we know concavity, it will give us understanding whether revenue, for example, growing fast or slow. Let's say if we have concavity like this, and let's say you're moving by car uphill and downhill, and compare it to this one. If you're moving uphill with this picture and downhill with that picture, which one will be faster going uphill? Well, probably this is faster than this one, fast and slow, because here I have to have more acceleration to go up to the maximum point, either on this picture. And then if you go downhill, this one will be slower than this one. So by the shape of the function, you can understand how fast your function moving in the inflection point. Now it's your turn to practice.